some basic things, right? We said number one, the roots of our quadratic function would be the values of x where the curve cuts the x-axis, right? What are the values of x that the curve is cutting through the x-axis? What are the two values of x? Anybody, online or face-to-face?
-1 and 5.
-1 and... Tell me, see that, Tyler. -1, it's cutting through -1 here. Follow my arrow, guys. It's cutting through -1 and it's cutting through 5. Now, I'm not even reading what the question asks it. I'm just trying to establish these things, right? Another thing. What is the value of my y-intercept, which will actually be the value of c? What's the value of the y-intercept in this quadratic curve? The value of c is the y-intercept. All you have to know these terms, you know, because if we don't know these terms, we lost in quadratic functions. We are lost. Talk to me. Excellent. Hill said it. -5 is my y-intercept. This new profile here, kinda something, right? You are, what's your name again? You are Jade? No, that's one of the Robin sisters. Are you one of the Robin sisters?
Yes, sir.
All right. Change your name for me now, please. Right. Let's go. So we go now again. The y-intercept is where the curve is cutting the y-axis. Has everybody seen this is -5? Tyler, you seen that? Right? So we established three things there. We established the two x-intercepts, which are actually the roots. We established the y-intercept, which is the value of c. ax squared plus bx plus c. The value of c is the y-intercept, right? What kind of curve this is? Is this a maximum curve or a minimum curve?
Minimum.
Jump up and see that. So everybody know what a minimum curve looks like. Your maximum curve will be what? The mountain. The minimum curve is the value. Let's look at some other things. What are... That's all. Hold on. Right, so we go in. So we know that minimum curve, right? So let me jump into the question. So the diagram below shows a sketch of a quadratic function. They did not tell us what the quadratic function is fully, right? We have y is equal to x squared plus bx plus c, right? So what is the value of a? What is the number understood in front of x squared there? Anybody?
1.
So we know the value of a is 1. We also know the value of c. What's the value of c? -2, no? -2, you said, no? What's the value of c? Let me see who was paying attention. Where is it there, Danny?
13.
Somebody said 13? All it wasn't here when I just said the value of c.
-5.
Yes, the value of c is your y-intercept, which is -5, right? Now, all this means here, let me separate it a little bit. All this means is that -2 is less than or equal to x, which is less than or equal to 6, right? Cool? So, it just means that all the x values for this curve starts at -2, which will be on this -1, and go straight to +6, which is on this side. Right? That's all it said. Now they said where b and c are constant, state the roots of the equation of this easy dog food question. What are the roots of my quadratic, guys? This is the simplest thing you'll ever get. So this is part 1. Let's let me get my pen. So part 1. Right. What are the roots? Roots of quadratic. What are they? So it'll be x is equal to -1 and x is equal to 5. Roots of my quadratic. I'm never put this in red because I feel like all in zombie mode here, boy. You say it's all in van who shut down. So note, write it over, Tyler, because all you're not remembering it. The roots of a quadratic function Please write it, everyone. Are the values of x where the curve cuts the x-axis, all right? That is what my roots of the quadratic would be. Everybody good there? I'll go in there. Part 2, food again, part 2. Right? This was part 1. This was part 1. Hey, I had to pause these things, but I realized when the files small, they uploaded fast. And guys, these videos are uploaded on YouTube. Nobody else could see them, eh? Only you all can see them, so it's unlisted. So it's only the link that I send you all is the only way to access it. So if you go on YouTube, you wouldn't see the videos, right? So to access the videos, you would not be able to like search my name and get the videos. You could only access it through the link that I sent you all. And it's now I changed it this week, so you wouldn't see the videos again. All right. So that's the only way to access it now, through the link that I sent. You can't access it from searching my name again on YouTube, right? I had to close up my class a little bit because people messaging me and telling me, so boy, this class real good, boy. I said, well, people paid for this class, you know, so I had to hide all my videos. All right, so let me go. Roots was part 1. The next part, they ask us determine the value of C, all right? Value of C. So who could tell me what the value of C is? I fed up Satan.
-5.
All you're listening now, value of C, right, would be, well, I could put equal to -5. Everybody good there? So we have C, we have our roots. They now want us to show that B is equal to -4. Now here what I'm going to do, I'm going to write out this quadratic equation above here. So watch it. So this was part 2 have an A and a B. So this is part A. All right. So I put it in red here. C. So write it down, please. C is the y-intercept. All right. So there we go. C is the y-intercept, right? So we're going to part B now. So what's going on here? Because I'm sure those who attempted the worksheet, Robinson, lock in. I'm going to ask you some questions just now, Robinson. Right. Show that B is equal to -4. So what we're going to do? This was the initial equation they gave us. They gave us x squared plus bx plus c is equal to 0, right? Now watch this. And we just found c. So what can I rewrite this as? It'll be x squared plus bx plus what? Well, it's not plus.
-5.
Right.
-5.
5. So I can just put -5, right? Because a plus and a minus is a
-.
right.
Negative.
Now I have 2 roots of my quadratic, which is x is equal to -1 and x is equal to 5. Now, any value of x that I plug in here I'm supposed to be able to get 0 when I work it out, right? Any value of x. So you have an equation already. You just need to plug in any one of these values of x. So I'm just going to use the positive. So when x is equal to 5, I'm going to plug that in here. So I'll have 5 squared plus b by 5, which is the same as 5b minus 5 is equal to 0, right? So let's work. 5 squared is what? Anybody? 5 squared?
25.
25. So 25, I'm putting the minus 5 next to the 25, right? Minus 5 plus b multiplied by 5 is the same as just writing 5b. Is everybody clear there? Equal the 0, which is on this side, right? 25 minus 5 will be, can I carry the 20 here one time, my children? Huh? I carry 20 there one time. I'll keep up, eh? So positive 20 will become what?
Negative.
Right? 0 minus 20 will just be minus 20, right? So I'll have here now 5b is equal to minus 20. I want to find the value of b. What I need to do here? Divided. So b is equal to negative 20 divided by 5. B is equal to negative 4. Is that what they asked us to show? Was it negative 4? Right. Look at here. So you just put a little box underneath here. Shown. Now I actually want to show you all what would have happened if I use negative 1 instead of the I'll write it in black. No, I'm writing it in a different color, orange. So if we used x is equal to negative 1, watch it, right? Put a line here. Now let's extend the line accordingly. Right. If we use x is equal to negative 1, right? Watch it. We're using the same equation, right? So you'll have negative 1 squared plus b by negative 1 minus 5 is equal to 0. So watch how it will work out to the same thing. Negative 1 squared will be negative 1 multiplied by negative 1, which will be positive 1. This b multiplied by negative 1 will be negative 1b, or just negative b minus b, right? I'll put the 1 in front. Negative 1b, right? And then you still have the minus 5, right? So let me put it this will be minus 1b. We are going backward. All right, so this will be minus 1b, and then you still have minus 5 is equal to 0, right? So this 1 and this minus 5 could work out. So I could put 1 minus 5 minus 1b is equal to 0. 1 minus 5 will give me negative 4 minus 1b equal to 0. When I carry negative 4 here, what do I do with it?
Positive.
Plus, right? So this will be 0 plus 4, which will be 4, right? Then you have to take this negative 1 and divide it here. So b will be equal to 4 divided by negative 1. B will be what? Negative what? 4. And it will go to the same thing, my children. Doesn't matter which one I use. Right? Shown. So you could have used the negative 1, or you could have used the 5, which are the two roots of the quadratic. So I need you all to copy. State the coordinates of the minimum point of the graph of the function x squared, y is equal to x squared plus bx plus c. Now, my children, if all you cannot tell me what represents the coordinates of the minimum point, I will start to fling down laptop and think here in this lesson sum, right? So we're on part 3. So kindly give me what the coordinates. So this is why I need you all to do homework. So like for homework, you'll have to turn back to try to figure out what represents the coordinates of the minimum point. That's why we need you all to do homework, you know. What represents the coordinates of the minimum point? Negative h cover. Tyler, that's save all the information on our laptop going on the ground. Right? Negative h comma k. So my children, this is for, I put in it here, right? For a quadratic function ax squared plus bx plus c. Right, Priya? Priya, hear me? What is the value of h? What is h given by? H is equal to?
C.
No.
X.
No. We have a formula for h. What is h?
2.
B over 2a. That's supposed to be in all the memory. K is equal to?
4 is
All I hear is my children, I cannot learn these things all. Rishana, I cannot sit down and learn this for you. You had to write this out. I just made my son write out thing 10, 20 times because his memory not as good as my daughter's memory. So I don't realize already. So I just am writing over things for it to stick. Right? So there we go. I write it on the quadratic above. The quadratic above was given as y is equal to x squared plus bx, right? Now plus bx, we just found b to be negative 4. Everybody agrees? So it will be plus negative 4x. Now a plus and a minus is a minus. I hope you'll see this as I write it in there. And then it will be plus c, but c was negative 5. So I'll have to put minus 5. This here is actually my quadratic. Go ahead. Yeah, 4a. Very good. Very good. Right? So it's 4a, not 4ac. Right? Everybody good there? Robinson. Robinson number 1 and Robinson number 2. All I do my homework? The 2 Robinsons.
Yes, sir.
Yeah? All I get all this?
Yes, sir.
Right. So here what? Tell me what's A, what's B, and what's C here? Robinson. Robinson in yellow. A is equal to what? She watched it also see if she went yellow. What is A? A is equal to what?
You mean A have 1, 2, and 3?
1. A is 1 because it's in the number in front x squared. What is B?
What do you mean, sir? I have like 1, 2, and 3. Which part of the question? I mean,
No, we're looking for A, B, and C to work out this quadratic. Now, the function is of the form ax squared, which is this A, the number in front x squared. This is B, the number in front x, and C is the number by itself, right? So from this quadratic here, what is A? I put it for you. A is 1, right? What is B? B is what? What's the number in front of x here?
4.
Negative 4, sister, not 4.
Negative
4. And what is C?
Negative 5.
Right. So we're talking about values for my quadratic here. I don't know what number you was talking about. So B is equal to negative 4 and C is equal to negative 5, right? So come on, let's work, guys. All the killing me here. All the killing me. H is equal to what's B? Over. Right? Let me work it out right here now. What H will be? Therefore, H is equal to. Where get it, Tyler? Positive 2 or negative 2? Look, I have a negative 4 here, big brother. So it'll be negative 2. Right? Tyler actually did his homework here. He just get positive 2 instead of negative 2. Right? Janae, you do your homework, sister?
Yes, sir.
Niceness. Right, so we found H. H is negative 2, right? We're going to K now. Somebody call it out who did it now. K is equal to 4 by what?
4 by 1.
Excellent. By? 4 by
Negative 5.
Negative
5, right? Rashana wasn't here, yeah?
Take away.
What's B?
Take negative 4 square.
Where you get, it's 4. So where I get 5 from? Okay. Yes, B squared.
Is
Right?
negative 4.
Excellent. Amelia.
Divided by 4 by 1.
Excellent. Right? So give me some answers there, Rashana. Kasi I calculator. Work out the top press equal, and then divide by 4. Wait, you work it out, you get us? -9 is the final answer, right? You divided by 4 already, Rishana? All right. -9 is key. So therefore, the coordinates of my minimum point would be -h, which would be negative. Let me put that -h comma key, which will be negative of -2 because h is -2, right, Hill? H was -2, so it'll be negative of -2, comma k, which is -9. But a minus and a minus will give me a, so it'll be 2 comma -9. Boom bang.
So I could just go for some water, please.
Yeah, bro, no problem.
So can I get a snack?
You want me by fair?
So I asked it.
Yeah, do it, sister. Do it, man. Okay, we have number 10. Let's point out the obvious. I'm asking questions. I ask it every class, every question. Define the roots of a quadratic for me. The roots of a quadratic are what? What are the roots of a quadratic? Come on, we just did it.
The values of
x, where the curve cuts the x-axis, right? Okay, so the values of x where the curve cuts the x-axis. Simple as that. Using our visual, our eyes, what are the values of x where this curve is cutting the x-axis here?
-3 and 1.
Oh, let's see that? No, they're probably able to zoom in at home, or they can't zoom in here. Well, we can't. -3 and 1. Everybody good there? Right?
Yeah.
I'm zooming back out. Let's look at some more obvious things, right? What is the y-intercept here? Kind of not seen it good, but you know what it is. What's the y-intercept?
-3.
Excellent. The y-intercept is the value of?
C. No, what?
When I do this, so they don't see this, see? Yeah, C.
Okay.
Right?
Oh.
We got there, Priya? The value of C, right? Now look, they give you the quadratic right here next to the curve, right? That is the definition for the curve, right? Let me ask some other question. What's the value of A? It's a little blurry, but you all seen it. I know you all seen it. What's the value of A? 1. Beautiful. What's the value of B? What's the value of C? So we know all these things before we even jump into the question, right? There we go. The scale, right? Use the graph above to determine the scale used on the x-axis, right? Oh, this is a strange question, but I love it. They want the scale used on the x-axis. Who could tell me that? We did graphs before we did this, eh? So we have, this is 10, part 1. What's the scale on the x-axis? 2 centimeters to? Oh, let me come up proud here, boy. 2 centimeters to 1 unit. That's the scale on the x-axis, right? That's out of curiosity. What's the scale on the y-axis here? 1 centimeter to?
2 units.
No, sister. Where you get 2 units?
Sorry, sir.
1 centimeter to 1 unit, right? Cool. So we go in. The value of y for which x is -1.5, right? So x being -1.5, look at it here. This is where we had a lock in, right? The value of y for which x is -1.5. Can we all agree that -1.5, let me write it red. Hold on. -1.5 will be in between here. Can we all agree on that? Huh? It's between -1 and -2. Agreed? So they want the value of y for which x is -1.5. Stay with me, my children, because I'm going down to the graph. Right? Boom, bang, bang, bagalang, boom. Right, I reach the graph there, so I stop in here. So could we go to the left now? Not the left, is the left? No, the right. All right, so let go. We go now across. We're going across to the y-axis to see what this point lines up with for the graph, right? So we counted in what here? This is this is negative 3.2, because I don't see we counted in 0.2s. Negative 3.4, negative 3.6, negative 3. Boom, bam. I put 5. I get 5 from negative 3.8. Everybody good there? So the value of y would be, so value of y is equal to negative 3.8 when x is equal to negative 1.5. Who doesn't understand that? Ask all the questions. Let me see what the next part of the question asking. The value of x, the values of x for which y is 0, right? So the values of x for which y is 0 are actually, y is 0 on this line. Everybody agrees? On this line here, y will be 0. Tell me if all agree here, Tyler. Talk to me, Tyler. So what are the values of x on the graph for which y is 0? Talk. What are the values of x on this graph when y is 0? The values of x on the graph, right? On the curve, right? We're not concerned about the other points. We're just concerned about the points that line up with
negative 3 and 1.
Excellent, which are also called the roots of my quadratic. So this is just a fancy way for CSEC to ask you what are the roots of this quadratic. You hear me, Sister Rashana? Let us write down the roots of the people quadratic, please. So I'm going to write it down here. All right? These questions, these topics, very exciting, eh? Very. Let me see this man mad in the head, you know. So this was part 3. Right? So the values of x would be x is equal to negative 3 and 1. And x is equal to 1. Right? Okay? X is equal to 1, x is equal to negative 3. Also known as my what? What are these? What are these values of x called? What are these values of x called? My roots. Roots of the quadratic. Please write it, Tina, because all you're forgetting. Right? Roots of the quadratic function. Thank you, my children. After today, listen, after today, I not do over quadratic functions and normal functions until probably all you start CXC past papers, because all you see how much classes we spend on this. We spend 3 classes on this, This is the 3rd class, right? Everybody good there? Tyler, talk to me. Right, last part. CXC is asking for the range of values of y, giving your answer in the form A less than or equal to y less than or equal to b, where a and b are real numbers, right? So let me explain what I mean by the range of values of y, right? So your domain would actually be your x values and a range would be your y values, right? So I want to know what are the y values that cover this curve. Meaning, like, what is the lowest y value and what is the highest y value? So what's the lowest possible y value?
Negative 4.
Excellent, Jenny. Yeah, we are passing them up today, girl. Come on for them. You see that there? The lowest value that y could be is this point here, which is actually the minimum value. Right? Everybody good there? And what's the highest value that y could be? The tip top.
5.
What is the highest value that y could be? 5. Right? All you see that? Brother Tyler. Right. So watch it. All they want us to do here, right? They say to write it like this, Yeah, my Priya? They say to write it like this, sister. So we go in. So the least value is less than or equal to y, meaning that. So I'm going to put negative 4, which is the least value, is less than or equal to y, which is less than or equal to what was the greatest value? 5. So it simply means that y could be any value in between -4 and 5. Simple as that. That's right, guys. This battery got dead in this secondary lap, in the second laptop here. When I do these things doesn't seem easy to you all. Like when I do it for them. But when I go home, like all it doesn't see it. Alright? Right. So the note I want you all to put is your range. Anytime you hear the word range being thrown around, your range will be your y values, right? So note, Tyler, write this, right? Range would be your y values. Okay? Anytime you hear range, we talk about y values. Now, I just put that first because that relates to the question we just did, right? And your domain would be your x values. You all good there, my children? Well, you're supposed to eat up these questions of homework, eh? Domain range. That come on, pause this thing, by. Well, wait, I have to go back through this, eh? I did not unpause the recording, so let me just go back to number 1. We wanted to find g of 2, right? Which is simply equal to 5 minus x squared, but instead of putting x, you're going to be putting the 2. 5 minus 2 squared will be 5 minus 4, which gave us 1. Next, we need to find f negative 1 of 3. But you need to find f negative 1 of x first, right? What I did is I wrote down what f of x is. It's 2x minus 1 over 3. I need to replace f of x with x, and I'm going to replace x with y. I need to make back y the subject. So I carry 3 to the right. I multiply x by 3, which is the same as 3x. Now I'm going to carry negative 1 to the left. So instead of minusing, I'm going to plus 2y, right? Woo. What's the last thing I have to move here, my children?
The 2.
The 2. What do I do with this 2 when I move it to the left? Divide it. Excellent, right? So this will be 3x plus 1 all over 2 is equal to y. But the last step is to replace y with the function, the inverse of the function that we are looking for, which is f negative 1 of x is equal to this. Now, the question asks me to find f negative 1 of 3. So what do I replace x with here, my children? 3 by 3 plus 1 over 2, which will give me what? What is my answer? 5. This is 9 plus 1, 10, 5, right? Excellent. Everybody good there? Did we find the composite function? He says that easy fix, but I fed up at that van way. There we go. Right. Composite function, right? We put in one function into the next. Let me just write down what the two functions are, right? Give me what f of x was again. What f of x is?
2x subtract 1 over 3.
2x minus 1 over 3, right? And give me g of x. G of x is what? 5 minus x squared. So we put in g of x into f of x, right? It takes the place of x here. This whole thing, right, takes the place of x here for the composite function. Everybody good there? So f g of x is going to be 2 by, instead of putting g of x, I'm going to be putting, sorry, instead of putting x, I'm going to be putting what g of x is, right? So it's be 2 by 5 minus x squared minus 1 over 3. Everybody good there? Did they say to simplify it? Watch it. Y'all saw this? Y'all saw this?
Yes,
so
sir.
what we need to get rid of here? What we getting rid of first? Brackets. Boom.
The bracket.
On top of things, right? All on top of things. So 2 by 5 is?
10.
minus 2 by negative x squared will be 2x squared minus 1 over 3. Now, I can say 10 minus 1. 10 minus 1 will be what? 9? So this will be equal to 9 minus 2x squared over 3. Now, I can't take this 3 and divide it by both terms above here. So this will be 9 divided by 3 minus 2 over 3. You can just leave it as 2 over 3x squared. Cool? 9 divided by 3. 3. So this becomes 3 minus 2 thirds x squared. Cool? Right?
Yes, sir.
Not the government. Okay, sketch the graph of the function g of x in the space provided below. On your sketch, indicate the maximum minimum point and the roots of the function. Right? So I'm going to write what is this here? And next part of the question look like? Oh, this question is a long way. This was our number 9 or number 8. Right, let go. So we're going to sketch g of x. So I'm going to write what g of x was here. G of x was equal to 5 minus x squared. Everybody good there? Right? Now on this, they want us to show the maximum / minimum point, right? Whether it is a maximum or a minimum. They also want us to show the roots of the quadratic function. So we need to find the roots and we need to find the maximum / minimum point, right? So let me go. My max or the coordinates, I should put the coordinates of my maximum / minimum point would be, so coordinates of max or min point, because we don't know what is yet. Min point is given by, let me see who on top of things is given by what? Is given by what? Negative h, comma. So we need to find h and k. Come, give me my formulas. This is all. Let's remember these things, you know.
B over 2.
B over and
B
k
over
equal to
4ac
minus b
plus
squared
b
over
squared 4a.
4a. Excellent, right? Now, look at these changes here. This quadratic, g of x, I'm going to try to write it in order, right? So I put in the x squared first. So it's negative x squared. Now, this is actually plus 5 here, right? So it's just plus 5. So let me see you thinking on the different levels, right? On a different level. So a, what's the value of a from this quadratic? What is the number in front of x squared? Negative 1. Negative 1, Jimmy. Negative 1, right? Now B, you all seen any B in this question? In this quadratic, it's a quadratic, right? There's no B. So what do you think the value of B is?
1.
No, sister. One says if there was x alone, if you had x alone, then it will be 1 is the value of B. But there's no B, right? So B is equal to 0. What's the value of C, my children?
5.
Excellent. So you have your A, you have your B, you have your C. So I want you all to find H, find K, and then we have to find the roots of the function, which means we need to solve this quadratic, right? We need to solve it. But find H and K here first to me, quickly. I'm giving you all one. All right. So let's run back through this again. We had g of x, which is equal to 5 plus x squared. They want us to indicate the maximum / minimum point and the roots of the function, right? We already have the maximum point to be negative. Well, maximum or minimum is negative h comma k. We have h is equal to b over 2a. K is equal to 4ac minus b squared over 4a. From this quadratic, we determine that a is negative 1, b is 0, and c is 5. So let's work. All right, so coming on this side here, h should be equal to, what is b? B is 0 over 2 by negative 1, which works out to be what? 0. H is 0. And then k will be 4 by 1, negative 1, sorry, by 5 minus 0 squared. Right? All over 4 by negative 1.
Negative 1.
Right? So let's work. This will be equal to what? We're getting here when you work out the top. Negative 20 divided by negative 4, which is at the bottom, would give you 5. A is 5. Right? So therefore, the coordinates of my min or max point, right, is equal to negative h. It have no such thing as negative 0. So it'll be 0, 5, right? Now there's a point to note, right? Note.
So I get negative 5, okay.
Negative 5, nah, it'll be positive because 4 multiplied by negative 1 is negative 4. Negative 4 multiplied by 5 is negative 20. And then 4 multiplied by negative 1 will be negative 4. So negative 20 divided by negative 4 will be positive 5, right?
All right.
So when A is positive, right? So wherever A is once is positive, this implies a minimum curve, right? So you can actually watch the value of A and determine if your curve is a minimum or maximum, right? So like what happened, min slash max, I could have just put max because it actually is a maximum curve, right? So when A is negative, right, negative, this implies a max curve, right?
I'll be right back with that graph, okay?
Yeah, go ahead. Here will be 5. Here will be negative 1, negative 2, negative 3, negative 4, negative 5, right? So label out a graph with us these things, right? And then let's sketch. Right, so we need the roots of the quadratic. Right? So this will be given by, I have my quadratic function, which is actually negative x squared plus 5 is, I'm going to put this equal to 0. Right? Why am I putting this equal to 0? Is because I'm trying to find the values of x when y is 0. Right? So that's why I put this equal to 0. So what I can do here is I want to actually carry this x squared here so that it will become positive, right? So I'll have 5 is equal to x squared because it will be 0 plus x squared, right? Which is simply x squared. Now, at this point here, now this is how you solve your quadratic if you have no b, right? This is all you have to do. Once you have no b, this is all that you do, okay? So I'm going to put that in red here. Solving a quadratic when b is equal to 0. That's basically what we're doing here. Solving a quadratic when b is equal to 0. So what do I need? I need to find the values of x, right? So I'll need to find the opposite of square root here. What's the opposite of square root? Right. No. Sorry, the opposite of squared is square root, right? Sorry about that. No. Square root, when you find a square root, is actually going to be plus or minus the square root of 5. Right? So you're going to have two values of x here. You're going to have, branching off into 2, you're going to have x is equal to positive square root of 5, and you're going to also have x is equal to negative square root of 5. Everybody good there? Okay? Talk to my guys. All right. So, could somebody tell me what the square root of 5 is? Approximated to 2 decimal places, right? 2 decimal places. What's the square root of 5? 2.24. So that'll be 2.2. Agree? And it will be positive 2.2 and then it will be negative 2.2. Everybody good there? To 1 decimal place, sorry. So I have the roots of my quadratic. So I'm scrolling up, I'm scrolling up. Or you all need to write this. Write it quickly. We going up, right?
So I still writing it down.
Oh, sorry, Amani. Go ahead. Right. So here we're going to plot first. I want to plot the roots of my quadratic, right? So it's 2.2. So where would 2.2 be, my brothers and sisters? Would it negative 2.2? Can we all agree that negative 2.2 will be here? X marks the spot, right? Because every small dash will be 2.2, 2.4, 2.6 going up the road, right? It's going up in 0.2s, right? So plot the first root, and then we're going to have the second root, which is positive 2.2, which is going to be here. Cool, Priya, Cool, Roshana, Tyler, Hill. I have my two roots here. You have that, Roshana? Positive 2.2, negative 2.2. I just put that down, right? I also have to plot my maximum point because A is a negative. So therefore, you know a curve going to be a maximum curve. This is probably one of the only maximum questions I've ever seen in CXC. It has always been minimum, barely been maximum. So my maximum point, which is negative h comma k, is 0 comma 5, right? It's going to be 0 on which axis, my children? And
X.
on the, everybody good there? So 0 on the x is actually on this y-axis, and 5 is up here. Can we agree that that is up here on this axis itself? Yeah? Right. So we're going and freestyle, we're going to sketch a graph, right? Sketch means you just draw it freehand, right? So you can start like at the base here, like anywhere you want to start. You come, you reach here, boom. Then you go up, you come here, boom. Remember, you're not V'ing it, you're coming through here. You had to come through the two roots. Hey, boy. I miss, boy. All right, I want to do that over. Undo. Insert curve. Draw curve there, Tyler. All you're showing is your two roots and your maximum. I'll lock you in here, right? All right, boom. Yeah, I think we bad up there. Talk to me, how we looking? And you're supposed to label a graph anytime you draw a graph, eh? So this graph was actually G of x. G of x is equal to x squared. No, it was negative. Is 5 minus x squared. Let me put like how they originally had it. 5 minus x squared. Cool? So sketch this graph, please. Let me zoom in a little bit for you all. Sketch the people graph. I'll do this one because this is like a strange question that came for this year. Now they said in the graph above, draw a tangent to the curve at x is equal to 1, right? So x being equal to 1. Now you realize I didn't even put it in here. Where would x be equal to 1, guys? You realize I didn't put it in. You all see that? So x, I'm going to call here 1, right? This is where 1 is. Okay? You all know what a tangent is? If I'm doing a tangent to the curve at this point? All right, let's write a definition for tangent. All right, so a tangent is a straight line that touches the curve at exactly 1 point. Right? Curve at 1 point, right? So I'm going to draw a straight line, and if I want it tangent to the curve at the point where x is 1, it must be touching the curve at that point, right? So I'll draw it in red. So here what I want to do, I come in, so boom, let me draw the line first and I'll just move it, right? Oh, come up there. All right, so the thing about this tangent, right? This tangent, we could structure the question to actually touch the curve. Let me go up a little more. Right, you all see that? Now, when it touches the curve, right, it could pass, look at passing through this point here, which is, I think it's supposed to be structured to pass. Oh, I put one as here. You all see these ones here? Hold up. I did not see these ones. You all seen this one here? That hidden.
Yes, sir.
Look, 1 and 1 here, -1. So the tangent to the curve is actually at this point here. This is where 1 is. You all seen that? I did not see that. You all saw that one? Look, the one hidden here. Look at there.
Yes, sir.
Yeah, look, one hidden. CSEC wicked, boy. Right. So I'm going to put this line up here. So we're going back up. Let me go up. I'll move that line as now. Eh? Right. So this had to come so. Let me go. Still had to come wrong somewhere because it's supposed to touch the curve at that 1 point alone. Right. Right. That look more like it there. I feel I had to go up a little more. Everybody good there? Tangent to my curve. Thank you, CSEC, for hiding that one there. Right? So we actually have the point where the curve and the tangent meet. What is the coordinates of this point here? Who could tell me? What are the coordinates of this point? 1 on the x-axis, comma
3.
1, comma 3, right? So we know where the curve is cutting our tangent, or where the tangent meets the curve, right? So on the graph, draw the tangent to the curve at this. So we already did that. Use the tangent drawn to estimate the gradient of the curve at x equals to 1, right? Now, if you want the gradient at this point, you actually need to have 2 points on this line, right? So at this, yeah, go ahead.
Is it not -1?
Where is the -1?
Oh,
No,
if
it's
in the line.
+1. Yeah. So to find the gradient of the curve at this point, you will need to have another coordinate on this point, right? So right. So when this tangent is extended to see where it cuts the y-axis, it cuts the y-axis at 0, -2, right? So I have 2 coordinates on my line, so I can proceed to find the gradient of the line. Now let me see who remembers what my gradient formula is. Gradient is common m, right? So gradient will be equal to anybody.
Y2
Y2 minus
minus Y1
Y1 over
X2 minus
M, I'm sorry, X2 minus X1. Well, you must remember these formulas. And this is given 2 coordinates on the line, right? These 2 coordinates would be x1, y1, x1, y1. I don't like how I make this one. x1, y1 and x2, y2, right? So I just want somebody to give me the coordinates here again. It was 1, 3 and 0,
0, 2.
So I'm going to put a little x1 above here. So this is your x1 This is your y1. This is
So
your
it's
x2. This is your y2. This is -2.
Yes, sir.
Right, everybody good
Negative
here?
2.
Right. So let me go. I want you all to find the gradient of Lord Father. What is y2, my children? -2 minus what is y1?
3,
3 over what is x2
0.
minus x1 1. So what would my gradient be here? Remember, gradient is represented by common m. So common m, which is my gradient, will be equal to 5, because it will be -5 over -1, which will give me +5. Everybody good here? Write down the equation of the tangent in the form y is equal to mx plus c, right? So we actually have c. What is c again, children? Let me see who fallen. C is the same thing here. This is the quadratic. C is the y intercept. So we actually have c. What is c here? Where is this line cutting the y-axis? At what point? This is the value of y, where c is cutting the y-axis, -2. So we already know, well, c is the y-intercept, which is equal to -2. Okay, let me write this a little different. I'll just put therefore, c is equal to -2. And we have m. What's the gradient? M is equal to, this implies that y is equal to 5x, which is mx, plus -2, which will be -2. That's my equation. So let me go. I watched a video I posted on YouTube and had like 2 mistakes. And you hear when the video telling the children, somebody second and somebody third this, and everybody second and third, and it could be answered. Where y'all get here?
-5.
13. Look, somebody get -2, somebody get 13. You get 13.
I got -5.
I get -5.
Right, so this is
-5.
Then it will be 9, right? So it will become -9 minus 3. -9 minus 3 will be -12. -12 plus 7 will give me -5. Correct. That's okay. So there you go. That's one working. Next working. Y. So we could probably put on top here when x is equal to -3. Then we're going to do when x is equal to -1. So let's go. Y is equal to negative of -1 squared plus -1 plus 7. Where again here when you work out this?
So 5.
5, right? Somebody second 5. Second, third, fourth.
I got 5.
5, right? Positive 5
I
here.
got 5.
What kind of table? What kind of thing this is, boy? Negative, this will be +1. So -1 minus 1 is -2. -2 plus 7, yeah, correct. Right, so there we go. 1. When x, let me get some space here. When x is equal to 1, y will be equal to 1 squared plus 1 plus 7. Y will be equal to what?
3? No, wait, is 3?
3? No. What you again? This is not 3.
For the third one, sir?
Yeah.
7.
It's not 7. Oh yeah, it's negative in front there. All right.
Yeah, because what we would do is
right. 7 is the answer. Very good. Yeah, very good, Eden. All right, so let me just erase here. So this will be equal to -1 squared plus 1 plus 7. But 1 squared is 1, and then it will be -1 plus 1, which is 0, plus 7 is the answer. 7, all right? So let me go. 3. When x is equal to 3. So you'll have y is equal to 3, -3 squared, sorry, plus 3 plus 7. What is one working out to be? That would be what? 9? 9, negative
Try
9 plus
1, I think.
1, yeah.
The
Positive
last
1.
one is it.
Positive 1, right? Proper thing. So these here are all my coordinates, right? Okay, that I will now use to plot my graph. So on the grid below, draw the graph for this, what we have above, for negative 3 less than or equal to x less than or equal to 4. That means it's spanning from negative 3 to 4. But let's plot our points. So I want somebody to give me these coordinates. You all right on the table, right? So we start with the first coordinate. The first coordinate would be negative 3 on the x and negative 5 on the y, right? I'll make this a little bigger. Right. Negative 3 on the x, negative 5 on the y would be here. Everybody agrees? That's my first point. We good there, Tyler? Yes. Next coordinate, give me. I'm not going to mark up. Give me the next coordinate.
So it will be
Next coordinate. Negative 2 on the x and
I lose my words.
1 on the y. So that's here. Next coordinate. Negative 1 on the x and
5 on the y.
5 on the y.
It was 5 on the y.
Negative, that's all. Let me wait. This point is supposed to be underneath here. This is negative. This point is negative 5, not positive 5. And Priya?
Yeah.
That was saying now because I see what is not curve. Right. So this point is supposed to be down here because it's negative 5, not positive 5. Right? Then you have negative 2, comma, positive 1 or negative 1 for the second coordinate. Negative 2, comma, negative 1.
Yes, negative 1.
Right. And then what's the next one? Negative 1, comma, 5. Next one, 0 to 7. Next,
1 to 7.
1 to 7. Next,
2 to 5.
2 to 5. Next,
3 to 1.
3 to 1. Next,
4 to negative.
4 to negative 5 at the base here. So we plot the points. What we have to do on the grid below, they want us to draw the curve, right? Let's draw the curve, guys. U it, don't V it. Always tell all of this. All right? Make sure it's a U, not a V.
So there, next maximum point.
Yeah. So like of recently, they started bring plenty maximums, buddy. Dr. Marishana, this you here? You get through this? Look how awesome that curve is now, boy. Look how nice. So let's label our curve. Y is equal to negative x squared plus what? What's the rest of the quadratic here, Aiden?
Plus x plus 7.
Plus x plus
7.
right. That is what this curve is defined by, right? Y is equal to negative x squared plus x.
So here, man.
Yeah, now start here.
Alright.
Right, everybody good there? Right. Write down the coordinates of the maximum minimum point, right? Now you can't get it from the graph. Okay? From the graph, the maximum minimum point will be what? Definitely what's the value of x? What's the value of x here for this max point up here? What's the value of x, guys? 0.5 or a half, right?
Okay.
So it'll be 0.5, right? That's the x value. So we can put, yeah, it looked like 7.3 to me, but just, so I have 0.5 as the x-axis value, And then the y-axis value to me looking like 7.3 because it's between 7.2 and 7.4, right? So we go in. So I'm putting what I get in my graph. You all could put what you got in your graph, right? Okay, everybody gets 7.3 or looking like 7.2 or your
I got 7.2.
well, work with 7.2, right?
7.2 I
Mine's
got,
looking
sir.
right. Mine's looking like 7.3, so I will go with 7.3. Put what you got, right? Right, let me go. Write on the equation of the axis of symmetry of the graph, right? Write on the equation of the axis of symmetry of the graph. So the equation of the axis of symmetry will be given by what? Anybody?
The equation, the axis of symmetry. She said that the real long one will it be plus or minus?
Nah. The equation of the axis of write it down because only remember one thing. Write it down. Tyler, write it down. Huh? Yes. X is equal to negative h. Very good, Tyler. But still write it down. The equation of the axis of symmetry is given by x is equal to negative h. But point to note, this up here, which are the coordinates of the minimum point, is actually what? The coordinates of the minimum point is given by what? Negative h, comma. So negative h is actually equal to what?
0.5.
0.5. Excellent. It's not going to be negative 0.5. It's going to be 0.5. So x will be equal to 0.5 because this is already negative h. Negative h is the number in front here, right? The first number, the x-axis value. Everybody good there? Cool? Right. So write on that. Use your graph to find the solution of the equation negative x squared plus x plus 7 is equal to 0, right? So look at this. The equation, the solution, for an equation that is a quadratic would be the values of x. The values of x of my quadratic would be called the roots, well, not will be called, are called the roots of my quadratic. So they're basically asking us for our roots. So can we look at the graph because they said use the graph, right? We're going to look at the graph now. What are the roots of my quadratic from this graph? What looking like?
That is it's on the negative 2 side. Like I already see what
Right.
the
This looking like
decimal is.
negative 2.2, no, 2.4. 2.4 on my graph. What are the graph saying? This will
And
be
then
negative 2.4, and on this one here,
it's
this side here
3.2
is 3.4.
exact.
No, wait a minute.
3.2 for me, sir.
Yeah, it's 2 centimeters to 1 unit. So this will be 3.2.
Oh,
Yeah, that's the difference. So you're going up in 0.1. So this will be 3.2, sorry, negative 2.2 and 3.2 on my graph, right? So I'm going to write that in underneath here. So it'll be negative 2.2 and 3.2. That's the two values of x or the solution of the quadratic equation. So I want to write that here. Note the solution of the equation, is the values of x values of x where the curve cuts the x-axis, right? Also known as the roots. Okay? The roots. So, So we need to asking us to draw here. Let's plot these 2 points. So we plot in -3, -1, 0, 8, right? -3, -3, -1 would be here. -3 on the x, -1 on the y. Everybody agrees that's here? Right? Then the next coordinate is 0 on the x, 8 on the y. 0 on the x, 8 on the y is quite up here. Everybody good there? So let's draw a line from there to there, joining these 2 points. It looks like it's going to be a tangent. A tangent to the curve is a line that cuts the curve at 1 point. Okay, so this line is more or less cutting the curve at 1 point. Cool? Cool, Priya?
Yes, sir.
Right, that's the tangent to the curve. What is the coordinate that it is cutting the point at? -1, 5. Right? That's the coordinate of the point. Right? -1, 5.
For the gradient.
All right, so let me
Y2.
put it
Y2.
Subtract
Gradient.
Y1.
Right, so gradient of a line which is common m is equal to y2 minus y1 over x2 minus x1. Right? Look, we had the 2 coordinates on the line right above here. I'm going to put a little I'm going to put a small x1, a small y1, a small x2, and a small y2. Right. I'm a little distracted. Right. Let me go. Come, give me some digits here. M is equal to 3. I hear somebody say 3. 8. Thank you. 8 minus -1. Yeah, is y1.
And then
0 minus -3. So this works out to be what? 9 over +3, which will be 3. That's my gradient. But we also have the y-intercept. What's the y-intercept, guys? C, right? So what is the value of y where that line is cutting the y-axis are going up, right? What's the value of y? I could extend this line and follow one. So you can see that it's cutting the y-axis at what point? What's the value of y here?
8.
8, right? So I'm going to short back the people line. So that is your y-intercept. Just because we stop at 8 doesn't mean 8 is not the y-intercept, right? So 8 is the y-intercept. So we don't need to go and use the formula that I showed you all, right? And we could simply just put when C is equal to 8, okay, we have the y-intercept. Therefore, y will be equal to mx, which will be 3x plus 8 plus c, right? That's the equation of your line, right? So we had time. Oh, no, we don't really have time. How much more we have down here?